Alright, so let's look at the second question, which is valid anagram. This is also one of the easy question. So basically we have to tell that we are given two strings and we have to return true if they are anagram of each other or false otherwise. So what is an anagram? An anagram is basically it should have the same number of characters in both strings. So suppose in S there are 3 A's, in T there should also be 3 A's for it to be anagram, and similarly for all the characters. Their positions may or may not uh, be at the same index, but the number should be same. So let's talk about how should we solve it. So the first solution which comes to my mind is that we want to compare the count of each character in both the strings, right? So we would need map to store them. So maybe we need map to store them, and then we will compare both maps. That's the brute force approach which is coming to me. So what I mean is that let me declare two maps. One I would name MP1 and one I would name MP2. So what would be the key? The key will basically be my character, and my value is basically count of that character, so that should be an integer. So let's create two maps, MP1 and MP2. Now let's form this. So I will first traverse through my S string, and then I will just do something like MP of ch plus plus. So basically in counting the frequency of each character in string S and storing it in a map. The map's name is MP1, and similarly for T string it would be in MP2. So we have two maps and each of them have the count of each character in their respective string. So for it to be anagram, everything should match. If there is a single entry which is not matching, then we can surely say that it's not anagram. So I just need to traverse through the map and then compare. So let's have MP1. So I'm traversing through MP1 and basically I want to check if IT that should not work here because we want to access the character of it, so we need different identifier. So let's say int I is equals to so we know that the character is lowercase, so let's just go with char ch is equals to a and ch is less than or equal to z and ch plus plus. Now I don't know if this is right or not, but we'll figure it out later. So if my MP1 of ch is not equal to my MP2 of ch, then we can return false. These are not anagrams. If everything is matching, we'll successfully traverse through each of the character and return true. Now I don't know if the syntax is right or wrong, but let's check it. You get the idea, right? And it's definitely, oh, it's correct. Okay, so let's try submitting it and then discuss its time and space complexity. Okay, so we are getting it passed. Okay, let's discuss the time complexity. So what are we doing? We have 3 for loops in this code. One for loop is traversing each character of string s, another one is traversing each of t, and the last for loop is going through all the lowercase characters one by one and checking if the values of both maps are equal or not. So let's say that string s size was n, that of m size and that of t size was m. So we basically have let n be equal to my s dot size and m be equal to my t dot size, and then we can say, and the third for loop is basically running 26 times because there are 26 lowercase characters, so 26 is just constant. So the overall time complexity for this solution is big O of n plus m plus of 26. Even if you shouldn't write this 26, but it just means that there's a constant time, right? So n plus m is the time complexity. And what about space complexity? Since we are using 2 maps and both of them can have a maximum size of n and m, so the space complexity is also equal to n plus m. So can we improve on this solution? I think we can, because we're using 2 maps, and both maps, we don't need 2 maps. If or the solution is working, so I wouldn't say, maybe by some complex, not complex, but maybe we can do it with 1 map. So what we can instead do is that we will just use 1 map, and when we are traversing through the string s, we will increment the frequency of it, and when we are traversing through t, we will decrease the frequency of it, and then if any entry is not equal to 1, is not equal to 0, then we can say that it's not anagrams. So let's improve on it. So let's say we just have 1 map, and I'll just increment it here, and on this traversal we will just check if my is not equal to 0. This will result in correct solution, although our logic is correct, but I'll tell you why it will be incorrect. Basically what happens is that when you are declaring a map in C++, there is no entry present in there. Okay, let's submit it. There's no entry present in that, so by default it's 0, but okay, we are getting it passed. Alright. A better way, I think, since we are just dealing with 26 characters, is that we should have, and also a little correction, in my previous solution I said the space complexity is n plus m. it shouldn't be the case, because the size of map is basically the number of entries present in it, and the maximum number of entries present in both maps can be 26 only, because there are 26 characters. So the space complexity is almost constant, because we know the size of it. So let's solve it just by using a frequency array. So let's name it frequency, and since we know that all will be lowercase alphabet characters, so we can say that our size is 26, and we initialize all of them to be 0. Now once we are traversing through our first array, we can say that we'll just subtract it by a, because we want it to be in the range of 0 to 26. The ASCII code for lowercase a is, I think, 97. So if you don't subtract this minus a, if you don't write minus character a, then it will be frequency of 97 plus plus, and 97 does not exist, because we have defined our vector to just have 26 indexes, which ranges from 0 to 25. So that is why we are doing a minus a here. And similarly, we'll do a minus 1 minus a here, change its name to frequency, and then for each character we are basically traversing through our map. To make things simpler, we don't want to iterate through our characters. Instead, we can just iterate through our vector, which is 0 to 26 I plus plus, and if my frequency of ch is not equal to, instead of ch it will be I, is not equal to 0, then it means that there is a mismatch. If there's a mismatch, they are not anagrams. Let's try submitting this code, and yes, we are getting it passed. This solution, I think it's much cleaner, since we are just using a single vector and then we are computing it. Thank you.